In this video, I'm going to discuss how to graph y equals 3 cosine of x minus 2. What we're going to find in graphing cosine functions is the process is pretty much identical to graphing sine functions, except for one tiny little thing at the end. So, as we know, if we're graphing sine functions, the first thing we do is we identify the amplitude as well as the vertical shift. Again, the amplitude is the number in front of the function, and the vertical shift is the number at the end. We then find our maximum and minimum values by doing the vertical shift plus the amplitude, which in this case would be -2 plus 3, which would give you 1. And the minimum values by doing the vertical shift minus the amplitude, in this case -2 minus 3, would give you -5. We know that the period is equal to 2 pi. That'll change in future videos. And the scale, this doesn't change, is always the period over 4. In this case, 2 pi over 4, which is going to give you pi over 2. Now, let's graph it. So just like before, I want to put in my scale. For my y-axis, I need to make sure my scale gets up to 1 and all the way down to -5. So I'm going to do 1 up here, and that pretty much satisfies everything I need to do on the top. And then down here would be -1, -2, -3, -4, -5. For my x-axis, my scale follows this part right here. So my scale in this case is pi over 2. So I would write this on here. Pi over 2, pi, 3 pi over 2, and 2 pi. And on my other side, I'll do the same thing. -pi over 2, -pi, -3 pi over 2, and -2 pi. Notice how the spacing is pretty much equal. It's hard to make it perfect when you're graphing, but you want it to be as close as possible. Your graphs can look really funky. If you remember the next thing that we had to do, it's create these lines at the max, the min, and at the vertical shift. So I'm going to go ahead and create these lines. Again, when you make them, you want them to be dotted. I'm using a tool on the computer, so for that reason, they're just going to be solid lines. So that would be one of the lines. That's at the max. The next one would be at the vertical shift. That should be at -2. It's a little high, but actually I'm going to fix it. Did the same thing. Okay, we're going to leave it there. And then the last one should be at the minimum, which in this case is -5. Okay. Now, when I go to graph the points, here is where the difference between sine and cosine comes into play. Cosine is not going to start at the middle line like sine did, but rather it's going to start at the top. So when I'm on my y-axis, cosine needs to be right here at the top. Well, it's at its max. The only way it can go in both directions is down. It simply can't go up. It's as high as it can go. So moving along my scales, I'm going to go to the middle line, to the bottom line, and then bounce back up. Almost think of these lines as a ball just traveling through hallways and just bouncing back and forth off the walls. It's going to keep going until it hits either the bottom wall or the top wall. It's not going to bounce off the middle. Never have these graphs bounce off the middle. That's a huge mistake I see students make all the time. But rather, it only bounces at the ends. Pretty easy, right? And then all I have to do is connect these points. So I'm going to connect them with a curve. I'm going to go straight down through the middle. Whoop, straight down through the top. Curl it at the top. And should generally look something like that. And remember, always put arrows on the ends. So that's how you graph the cosine function. It's actually almost 100% identical to graphing the sine function. It's just you start in a different place. But as far as finding the amplitude, the vertical shift, the max, the min, the scale, it's all the exact same process.